What's up guys, this is Massey. Welcome to another video. In this video I want to show you some examples regarding remainder theorem. First example I have here, it says divide 3x cubed minus 2x squared minus 8x plus 10 by x subtract 1. It says express the result in quotient form, identify any restrictions on the variable. Write the corresponding statement that can be used to check the division and verify your answer. First thing, I need to divide this by this. So I have 3x cubed subtract 2x squared minus 8x plus 10 divided by x minus 1. 3x cubed divided by x is going to be 3x squared. Multiply this is going to be 3x cubed minus 3x squared. When you subtract these two cancels out and we have 3x squared minus 2x squared. That's going to be x squared minus, we need to bring the next term down because we have two terms here. We always need two terms here as well. So x squared divided by x is going to be just x. X times x, x squared. X times negative 1, negative x. Then you subtract it. These two cancels out and we have negative 7x plus 10. Then negative 7x divided by x is going to be negative 7. Then we multiply negative 7 by these two. Negative 7 times x, negative 7x. Negative 7 times negative 1 is going to be positive 7. Once you subtract them, these two cancel out and we have 10 subtract 7, which will be 3. So the remainder is going to be 3 in this case. What is going to be restriction? The restriction is going to be x minus 1 cannot be 0, which means that x cannot be 1. And we can say 3x cubed minus 2x squared minus 8x plus 10 divided by x minus 1 equals to 3x squared plus x minus 7 plus 3 divided by x minus 1, because this is the remainder. So it's going to be r divided by this expression here, x minus 1. And the corresponding statement will be 3x cubed minus 2x squared minus 8x plus 10 equals to 3x squared plus x minus 7 times x minus 1 plus 3, because that's the remainder. And how do we verify that? We just fold it in here, plus 3, and then we simplify it. That should be equal to exactly like this expression here. Let's see another example. So next example, it says divide 4x cubed minus 8x plus 5 by 2x plus 1. Identify any restrictions on the variable and write the corresponding statement. So we have 4x cubed minus 8x plus 5 divided by 2x plus 1. So 4x cubed divided by 2x is going to be 2x squared. When you multiply them, 2x squared by 2x is going to be 4x cubed. 2x squared by 1 is going to be 2x squared, and then you subtract them. When you subtract them, these two cancels out, and here we're going to have negative 2x squared minus 8x. Remember, this one is x, this one is x squared, so we need to keep both of them. Then negative 2x squared by 2x is going to be negative x. When you multiply, it's negative 2x squared minus x. When you subtract them, these two cancels out and we have negative 7x. Bring this one down, 5. Negative 7x by 2x is going to be 7 over 2. So 7 over 2 times 2x is going to be 7x. So it's going to be negative 7 over 2. Negative 7x, and here is going to be negative 7 over 2. Once you subtract them, these two cancels out and we have 5 subtract negative 7 over 2, which will be 8.5 or 17 over 2. So that's the remainder. So I would say 4x cubed minus 8x plus 5 divided by 2x plus 1 equals to 2x squared minus 8x minus 7 over 2 minus x minus 7 over 2 plus 17 over 2 times, or 17 over 2 times 1 over 2x plus 1. Because 17 over 2 is the remainder and it has to be over 2x plus 1. Or we can say corresponding statement 4x cubed minus 8x plus 5 equals to 2x squared minus x minus 7 over 2 times 2x plus 1 plus 17 over 2. And the restriction is going to be 2x plus 1 cannot be equal to 0, which means that x cannot be negative 1 over 2. So basically, in general format, we can say if you divide px over x minus b, it's going to give you the quotient plus the remainder over x minus b. And the corresponding statement is going to be px equals to x minus b times qx plus r. That's called remainder theorem. This is corresponding statement, and this is the division of polynomials. Let's see another example. Let's divide x cubed plus 6x squared minus 2x plus 1 by x plus 1, and then identify the restrictions. We have x cubed plus 6x squared minus 2x plus 1 divided by x plus 1. X cubed divided by x is going to be x squared times x cubed. X squared times 1 is going to be x squared. When you subtract them, these two cancels out, and 6x squared minus x squared is going to be 5x squared minus 2x. 5x squared divided by x is going to be 5x. So 5x times x is going to be 5x squared. 5x times 1 is going to be 5x. Then when you subtract them, these two cancels out, and we have negative 7x. And then we bring this number down, is plus 1. So we have negative 7 times x, negative 7x minus 7. When you subtract them, these two cancels out, and we have 1 subtract negative 7, which is 1 plus 7, that's 8. How do we write it? We can say x cubed plus 6x squared minus 2x plus 1 divided by x plus 1 equals to x squared plus 5x minus 7 plus 8 over x plus 1. The restriction x plus 1 cannot be 0, so x cannot be negative 1. If we want to write the corresponding statement, we can say x cubed plus 6x squared minus 2x plus 1 equals to x squared plus 5x minus 7 times x plus 1 plus 8, based on what we said earlier. So now let's see what is remainder theorem. Remainder theorem, it says when a polynomial function, let's call it p of x, is divided by x subtract a, the remainder is p of a. And we can say when px is divided by ax subtract b, then the remainder is p b over a, where a and b are integers. Let's look at the example. Here it says use the remainder theorem to determine the remainder when p of x equals to 2x cubed subtract x squared subtract 3x plus 4 is divided by x subtract 1. So if we want to use remainder theorem, it means that we need to find the remainder without dividing. So x minus 1 equals to 0, which means that x equals to 1. Then we sub it there. P x when equals to 1 is going to be 2 1 cubed minus 1 squared minus 3 plus 4. That's going to be 2 minus 1 minus 3 plus 4. That's basically is going to be 2, which means that if we divide this polynomial by x minus 1, the remainder is going to be 2. Let's take a look to another example. We can say use the remainder theorem to determine the remainder when p of x is 3x cubed plus 2x squared minus 5x plus 3 is divided by 2x minus 1. Now in this example we can say 2x minus 1 equals to 0, so 2x equals to 1, which means that x equals to 1/2. So it's gonna be 3 1 over 2 cubed plus 2 1 over 2 squared minus 5 1 over 2 plus 3. That's going to be 3 over 8 plus 1 over 2 minus 5 over 2 plus 3. And then that's going to be 3 over 8 plus 4 over 8 minus 20 over 8 plus 24 over 8 when we do common denominator. So we have 8 in here, 3 plus 4 is 7, plus 24 is going to be 31, subtract 20 is going to be 11, which is going to be 11 over 8. So you're going to say remainder is 11 over 8. Next example, it says determine the value of k such that when 2x to the power of 4 plus kx cubed minus 6x plus 8 is divided by x minus 1. Then the remainder is 3. So it says determine the value of k such that when you divide this polynomial by x minus 1, the remainder is going to be 3. So we're going to say we're going to have px equals to 1 because x minus 1 when it's equals to 0, x will be 1. So 2 1 to the power of 4 plus k times 1 to the power of 3 minus 6 times 1 plus 8. That's going to be 2 plus k minus 6 plus 8 equals to 3. Which means that 4 plus k equals to 3. So k will be minus 1. So the polynomial will be 2x to the power of 4 minus x cubed minus 6x plus 8. Okay, let's look at the next example. It says determine the remainder when each polynomial is divided by x plus 2. The first one is x cubed subtract 3x squared plus 3x plus 1. So in that case, it's going to be negative 2, because x plus 2 equals to 0, negative 2 cubed minus 3, negative 2 squared plus 3 times negative 2 plus 1. That's going to be negative 8 minus 12 minus 6 plus 1. That's going to make it as negative 25. Next one, negative 2x cubed plus x squared minus x plus 3. That case is going to be negative 2 cubed plus negative 2 squared minus negative 2 plus 3. So in that case, it's going to be 16 minus plus negative 4 is going to be plus 4 plus 2 plus 3. That's going to be 25. Next example is going to be negative x to the power of 4 plus 2x to the power of 3 minus 3x to the power of 2 plus 4x minus 5. Again, that's divided by x plus 2 as well. So we have negative 2 to the power of 4 plus 2 negative 2 to the power of 3 minus 3 negative 2 to the power of 2 plus 4 times negative 2 minus 5. So that's going to be negative 16 plus 2 times negative 8. Negative 2 is going to be positive 4 and negative 8 minus 5. So it's going to be negative 16, negative 16, negative 12, negative 8, and negative 5. That case is going to be negative 57. Next example. X to the power of 4 minus 2x cubed plus 3x squared minus 4x plus 5. So that's exactly the same as this polynomial, but the signs are different. That's going to be negative 2 to the power of 4 minus 2 times negative 2 to the power of 3 plus 3 times negative 2 to the power of 2 minus 4 times negative 2 plus 5. That's going to be 16 plus 16. Then we have plus 12 plus 8 and plus 5. So in that case, it's going to be positive 57. And the last one is going to be negative x to the power of 4 minus 2x cubed minus 3x squared minus 4x plus 5. That case is going to be negative 2 to the power of 4 minus 2 times negative 2 to the power of 3 minus 3 times negative 2 to the power of 2 minus 4 times negative 2 plus 5. That's going to be negative 16, positive 16, negative 12, plus 8 plus 5. That case is going to be positive 1. So the remainder is going to be positive 1 in this case. So basically, that's how we use remainder theorem to find out the remainder when we divide a polynomial by the binomial. I hope you enjoyed this video. Please leave me a comment if you have any question, and please don't forget to subscribe this channel. Thank you for watching and have a great day.